Here we're going to look at a different form of a line called the point-slope form. Now what we're familiar with is the slope-intercept form, which was y equals mx plus b. And remember, when you found the equation of that line, you had to find the slope and the y-intercept, the m and b. But once you did, say for example, you had y equals 2x plus 3. Your end answer for the equation of the line still had an x and a y in it. So there's points that the line passes through. But from looking at the equation, we could tell the slope was 2, and it went through the point 0, 3. What the point-slope form does is it allows you to use any point in the slope. Where the point-slope form is going to come from is from the slope formula. M equals the vertical change, y2 minus y sub 1, divided by horizontal change, which is x2 minus x1. What we do is you multiply both sides by x2 minus x1. And what that'll give you is m times that quantity equals y sub 2 minus y sub 1. Now, like I was saying over here, the reason I brought this up at the beginning was that when you have the slope-intercept form, there's still an x and y in our equation. The idea with the point-slope form is that we're going to be given one point and the slope. So here is where the slope goes, and then the point, you're going to put it into x1, y1. So the generic xy that we're left with is going to be x2, y2. So what we do is just turn those into the generic xy. So what we say is y sub 2 minus y sub 1, I'm just going to write that on the left side, equals m times x sub 2 minus x sub 1, and we'll change the y2 and x2 into just your generic x and y. So with the point-slope form, we're given the point x1, y1, and the slope. So xy is similar to the xy that's left over in the slope-intercept form. So using the point-slope form, in number 1, write an equation of a line whose slope is negative 2, passing through the point negative 3, 4. So we have y minus y1. Well, y1 is 4. So we have y minus 4 equals m times x minus x1. So that's going to be x minus negative 3. So we can clean that up just a little bit and say y minus 4 equals negative 2 times the quantity x plus 3. So what happens there, because that was a negative 3, you're subtracting that negative 3, turns into positive 3. So there is your point-slope form. So given that equation, it may look more confusing, but given that equation, we can see that the point negative 3, positive 4 is on the line with a slope of negative 2. If you wanted to clean that up into slope-intercept form, the y equals mx plus b, on the right-hand side over here, I'll just show you that. We take y minus 4. We can distribute the negative 2 to get negative 2x minus 6. And then if we add 4 to each side, we have y equals negative 2x minus 2, because adding 4. So that would be the slope-intercept form. And what you would gather from that is the slope is negative 2, just like it was here. But now we know it goes through the point 0, negative 2 for the y-intercept, which we don't have from the point-slope form. So the point-slope form just gives you a different way of graphing a line if you're not concerned with the y-intercept. So take a minute and see if you can do number 2. And pause the video, and then I'm going to get started on it. So when you do y minus y1 equals m times x minus x1. There's your slope-intercept equation. From there, we know it goes through the point 4, 1 with a slope of 3/2. And if you knew, if that's what you want to do is graph the line, that's all you would need. If you wanted to write it in slope-intercept form, you could by distributing the 3/2 and then adding the 1, which I'm not going to go through, but you could do that if you wanted to. Okay, the third one, when we try to do it here, notice we run into a problem right away that we have 2 points, and this point-slope form means that we need to find the slope. So we have the same problem as we would have with y equals mx plus b, in that we need to find the slope first. So that's a little annoying on this. So I'm going to find the slope the old-fashioned way, using the change in the y, so 1 minus 6 divided by negative 2 subtract negative 5. And you end up with negative 5/3 for the slope. So the slope-intercept, the point-slope form, y minus y1. So I'm just going to use the 1 and negative 2 for the x and y, x1, y1. So that'd be y minus 1 equals negative 5/3 times x minus negative 2. And you can clean that up to say y minus 1 and have a plus 2 in the parentheses. So based on that equation, we know it goes through the point negative 2, positive 1, and has a slope of negative 5/3. So that's using point-slope form. Honestly, I'm usually not overly crazy about trying to use that because I think it looks more confusing than y equals mx plus b. I think most students will look at y equals negative 2x minus 2 and be able to plot that better and understand that the slope is negative 2, goes through 0, negative 2, rather than looking at this equation. But the point-slope form does come up every now and then, so you do need to recognize it when you see it.